friends, till now we have done numericals on individual concepts. Now let us do some mixed concept numericals till JEE Mains level. Let us go ahead. So the first question, a copper cube of each side 40 centimeter floats on mercury as shown in figure. The density of copper cube is 3.2 gram per cc and of mercury is 13.6 gram per cc at 27 degrees Celsius. The coefficient of volume expansion of mercury and linear expansion of copper are 1.8 into 10 power 4 per degree Celsius and 3.3 into 10 power minus 6 per degree Celsius respectively. Calculate the increase in H, that is how much blocks sink further when the temperature rises from 27 degrees Celsius to 100 degrees Celsius. Fine. So interesting question. So basically the block is floating initially. So what will be the value of H? So for that, density of object by density of liquid, that will be equal to volume immersed by total volume, correct? So here volume immersed will be height into area. That will be side into side, okay, side into side. Volume will be side cube. That is equal to density of object by density of liquid. So S square cancel. So H is equal to density of object, that is copper. How much it is? It is 3.2 by density of mercury is 13.6 into 40. Okay. So 2 1.6, 2 6 are 12, 8, 2 0.8, 2 3.4, 2 1.7, 220. So this is H equal to 20 into 0.8, 16 by 1.7. Okay. So this will be approximately 9.41 centimeter. So initially 9.41 centimeter of the side of the cube is immersed inside this water. Okay. Sorry, inside mercury. Now, if the temperature is increased from 27 to 100 degrees Celsius, how much of this value will be immersed inside? Let us find that. So, at 100 degrees Celsius, again volume immersed by total volume will be equal to density of the object by density of liquid. Okay. So now at 100 degrees Celsius, say H dash of the length of the side is immersed in the cube. Then H dash into side by side cube it should have been. Okay, so that is equal to density of object by density of liquid. So this cancel. So H dash is equal to density of object by density of liquid into side. So basically temperature increased. So side length must increase, density of the object must decrease and density of the liquid must decrease, right? So from that I can write H dash as density of the object will be initial density, that is density of copper, by 1 plus gamma of copper into delta T, into side length, it will be initial side length, right, times of 1 plus alpha delta T, alpha of copper, coefficient of linear expansion, by density of liquid, that is density of mercury, by 1 plus gamma of mercury into delta T, correct? So H dash is equal to density of copper by density of mercury into initial side of this cube into 1 plus alpha of copper into delta T into 1 plus gamma of mercury into delta T by 1 plus gamma of copper into delta T. Okay. So this gamma of copper I can write it as 3 times of alpha, because coefficient of volumetric expansion, cubical expansion is equal to 3 times of coefficient of linear expansion. So from that I can write H dash is equal to density of copper by density of mercury into side length times of 1 plus alpha of copper into delta T into 1 plus gamma of mercury into delta T divided by 1 plus 3 times of alpha of copper into delta T. Okay. So alpha and gamma values are very small over here. So I can write H dash is equal to density of copper by density of mercury into side length, okay, into 1 plus, I can write alpha of copper delta T plus gamma of mercury delta T minus 3 times of alpha of copper into delta T. Okay, this is approximation. So H dash will be equal to density of copper by density of mercury into side length initially times of 1 plus gamma of mercury minus 2 times of alpha of copper into delta T. Okay. So one more thing is this density of copper by density of mercury into side length was the initial H value. So I can write H dash as H times of 1 plus gamma of mercury minus 2 times of alpha of copper into delta T. Okay. So H dash is equal to H plus H times of gamma of mercury minus 2 times of alpha of copper, right, delta T. So H dash minus H, that is change in the length, that is what we want, that is equal to H times of gamma of mercury minus 2 times of alpha of copper into delta T. Okay, so this delta H we want, so we just have to substitute the values. So delta H is equal to, H value is 9.41 into this gamma value for mercury, how much it is? It is 1.8 into 10 power minus 4 minus 2 times of this alpha for copper is given as 3 into 10 power minus 6, right, into delta T, change in temperature, that is 100 minus 27, that is 73. Okay, 73. So delta H will be 9.41 into 1.8 into 10 power minus 4 minus 6 into 10 power minus 6, I'll write it as 0.06 into 10 power minus 4, 73. So delta H is 9.41 into 73 into 1.8 minus 0.06, it will be 1.74 into 10 power minus 4. Okay, so when I simplify this, I'll be getting this value as approximately 0.12 centimeter. Okay, so as the temperature is increased, whatever is the increase in H value will be there, that will be 0.12 centimeter. Okay, so here what we have done initially at 27 degrees Celsius, what is the value of H we have found? Okay, then if temperature is increased, then what will be the value of H dash? So that we formulated and we got it in terms of H. So from there itself we got what will be H dash minus H, and we have substituted the values and we simplified and we got this delta H as 0.12 centimeters. Okay, so that is about this question. I hope you followed this. Now we can move to our next question. Next question. 3 rods of material X and 3 rods of material Y are connected as shown in the figure. All the rods are of identical length and cross-sectional area. If the end A is maintained at 60 degrees Celsius and the junction E is at 10 degrees Celsius, calculate the temperature of the junction B, C and D. The thermal conductivity of X is 0.92 CGS units and that of Y is 0.46 CGS units. Okay, so as you can see, there is this junction A and junction E. So junction A is at 60 degrees Celsius and E is at 10 degrees Celsius. Okay, and this rods AB, BD and DE are made up of Y material, and this rods BC, CD and CE are made up of X material, and they have given their thermal conductivities. Now they are asking us what will be the temperatures of this B, C and D junctions. Let us find that. Say heat is flowing from A to B, and say here it is splitting some into B to C and some into B to D. Okay, so whatever heat is flowing from A to B, let me call it as dQAB by dt, heat current, whatever it is flowing per unit time, heat flowing per unit time, heat current. So that should be equal to dQBC by dt plus dQBD by dt. Why it is so? Because as you can see, whatever heat is coming through this, it is getting split into 2. Okay, so junction rule, heat current entering should be equal to heat current leaving. Okay, so from this QAB, so KY, so KY times of A into change in temperature, that is temperature of B minus temperature of A by thickness, or by length, that should be equal to BC, that is made with Y material. So Kx times of A into change in temperature, so Tc minus Tb by L plus dQBD by dt, so that will be Ky times of A by L times of change in temperature, so that will be temperature at D junction minus temperature at B junction. Okay, so they are saying all rods are identical length and cross sectional area. So AL, AL, AN cancel. So what we are left with? We are left with KY times of TB minus TA is equal to KX times of TC minus TB plus KY times of TD minus TB. So let us substitute the values. So thermal conductivity for Y is 0.46, TB minus TA, that is 60 degrees Celsius, that is equal to Kx, that is 0.92 times of TC, we don't know, minus TB plus Ky, that is 0.46 times of TD minus TB. So again we don't know these two temperatures also. So here 0.46 into 2 is 0.92. So ones, twos, ones. Okay. So TB minus 60 is equal to 2TC minus 2TB plus TD minus TB. So let me send this TB, TC, TD terms to one side and the numerical on the other side. So I'll have minus TB minus 2TB, 3TB this side. Okay. 4TB minus 2TC minus TD is equal to 60. Let this be equation 1. Okay. Next, say at the C junction, okay, whatever heat current is entering through BC, that is splitting into two parts. Okay, one through CD junction and one through CE junction. So I can write dQBC by dt is equal to dQCD by dt plus dQCE by dt. Okay, so whatever heat current is entering this C junction, that is equal to dQBC by dt, and whatever heat current is leaving the junction, that will be dQCD by dt and dQCE by dt. Okay, so dQBC, that is Kxa delta theta, that is temperature at C minus temperature at B by L, is equal to CD, it is made of X again. So Kxa by L times of TD minus TC plus dQCE by dt. So that is again made of X. So Kxa by L times of TD minus TC, TC minus TB. Okay. So this will be TE minus TC. Okay. So as you can see, all are made of X material. So KXAL, KXAL, KXAL cancel. So TC minus TB is equal to TD minus TC plus temperature of E junction is 10 degrees Celsius minus TC. So minus TC minus TC minus 2TC, if I send to the other side, 3TC minus TB minus TD is equal to 10. So this will be our second equation. 3TC minus TB minus TD is equal to 10. Equation 2. Next, heat current entering the junction will be from here and from here, right? And leaving the junction will be from D to E. So I can write dQ BD by dt plus dQ CD by dt, that is the heat current entering junction D. That should be equal to dQ D by dt, that is the heat current leaving the junction. Okay. So from that, BD Y. So KY A by L times of temperature of D minus temperature of B plus CD X, KX A by L times of TD minus TC is equal to DY KY A by L times of TE minus TD. Okay, so A by L, A by L, A by L cancel. So KY, it is 0.46 times of TD minus TB plus KX 0.92 times of TD minus TC is equal to KY is 0.46 times of TE, which is 10 degrees Celsius, minus TD. Okay, 0.46 once, 0.46 twos, 0.46 once. So TD minus TB plus 2TD minus 2TC is equal to 10 minus TD. So 2 TD, TD and one more TD. So 4 TD minus TB minus 2 TC is equal to 10. This is the third equation. Okay. 4 TD minus TB minus 2 TC is equal to 10. Right. Equation 3. So we have 3 equations and 3 unknowns. So using these 3 equations we can solve. So let us go ahead. So I can subtract equation 2 from equation 1. So 1 minus 2. So 4 TB minus 2 TC minus TD. So minus TB plus 3 TC minus TD is equal to 60 is equal to 10. So subtract. Okay. So 4 plus 1 it will become, so 5 TB minus 5 TC. This will get cancelled, right? So is equal to 50. So TB minus TC is equal to 10. This will be equation 4. Okay. Next, second equation I'll multiply with 4 times and I'll add to third equation. So minus 4 TB plus 12 TC minus 4 TD is equal to 40. Third equation, minus TB minus 2 TC plus 4 TD is equal to 10. So when I add these two equations, these two terms will get cancelled. So minus 5 TB plus 10 TC is equal to 50. So if I multiply with 5 on both sides, so this will become minus TB plus 2 TC is equal to 10. Equation 5. So from 4 and 5, I can add 4 and 5 so that I'll get temperature at C junction. So I'll add 4 plus 5. So TB minus TC is equal to 10 and minus TB plus 2 TC is equal to 10. So cancel. So TC is equal to 20 degrees Celsius. Okay. TC is 20 degrees Celsius. So if I substitute that in fourth equation, so TB minus TC is equal to 10. So TB will be equal to 30 degrees Celsius. TB will be equal to 30 degrees Celsius. So once I got TB and TC, I can substitute in any one of the 3 equations, 1, 2, 3, and I can get the temperature at D junction. Say I'll take first equation. So 4 times of TB minus 2 times of TC minus TD is equal to 60. Okay. So 4 3s 120 minus 40 minus TD is equal to 60. So 120 minus 40 80 minus 60 20. So temperature at D junction is 20 degrees Celsius. So temperature at B junction is 30 degrees Celsius, temperature at C junction is 20 degrees Celsius, and temperature at D junction is 20 degrees Celsius. So here what we have done, we have chosen 3 particular points, B, C and D. Okay. So for those 3 points, what is the heat current entering and what is the heat current leaving? That we have equated, we got 3 equations in terms of TB, TC and TD. Then using these 3 equations, we got 2 more equations, okay? And using those 2, we got TC first, then TB we found, then TD we found, okay? So that is on a whole about this question. I hope you understood this. Now we can move to our next question. Next question.